Hey guys, welcome back. So we're now going over AMC 10A 2022 problem number 10. So this one says Daniel finds a rectangular index card and measures its diagonal to be 8 centimeters. Daniel then cuts out equal squares of side 1 centimeter at two opposite corners of the index card and measures the distance between the two closest vertices of these squares to be 4 square root 2 centimeters as shown below. What is the area of the original index card? Okay, so what I did for this one was I sort of looked at this. I think originally I did this problem in a much better way, but the truth is I kind of forgot how I did it. So I'm kind of looking at it as sort of a different way. So what I did was I kind of looked at this sort of inner rectangle here. Right? Sorry, I wanted to make that a different color. Let's make it red. So if I make this sort of inner rectangle, I didn't mean to make that cover anything. Well, basically what I did was I considered sort of this length, the inner length of this rectangle to be, I call it like X, right? And then this vertical length to be Y. So this distance I called X, and then this distance I called Y. Which would mean that like if I look at sort of this outer distance here, that would be Y plus 2, and this outer distance here would be X plus 2, right? And notice how like this diagonal here is 4 root, whoops, sorry, let me write that better. Oh, sorry about that. This would be 4 root 2, and then this diagonal out here would be, so like, from, well, like here to here has a distance of 8, right? So what I can do is I can draw two triangles, right? I can draw one, like the larger triangle, right? And say that this is X plus 2, Y plus 2, 8, right? And then I can use the Pythagorean theorem to say X plus 2 squared plus Y plus 2 squared equals 64, 8 squared, right? Okay, so I can do that, right? Then I can say, so based on that, right? So that means that X squared plus 4 plus 4Y plus 4 equals 64. I can sort of combine terms, so I can say X squared plus Y squared plus 4X plus Y. Oops, let me write that better than that. Sorry, let me just write that a little bit better. 4 times X plus Y would be equal to 64 minus 8, or 56, right? Now one other thing that I know is by looking at this red triangle here, right? If I look at this sort of this red triangle here, right, from the inside, I can say based on that, again, using Pythagorean theorem, I could say X squared plus Y squared is equal to 4 square root 2 squared, or X squared plus Y squared equals 32. Right, so I also know from Pythagorean theorem that X squared plus Y squared equals 32, which means I can substitute here. I can say 32 plus 4 times X plus Y equals 56, or in other words, so then by subtracting 32 to both sides, that's going to give me what, 24? So I'm going to have 4 times X plus Y equals 24. Divide both sides by 4, I get X plus Y equals 6. Right? So I get X plus Y equals 6. So then what I can do is I can then do a substitution. Actually, here, let me actually make this smaller so I have a little more room here. Right? Sorry, let me just, and I'm just going to try to, hold on. I'm just going to try to make a little more room here to write. So now what I can do is I can say that X equals 6 minus Y, or I could say Y equals X minus 6. Sorry, 6 minus X, right? So then by going back and doing, remember how x squared plus y squared equals 32, I can substitute and say x squared plus 6 minus x squared equals 36 minus 12x plus x squared equals 32, which I can simplify to be 2x squared minus 12x plus 4 equals 0, or x squared minus 6x plus 2 equals 0. I can then do the quadratic formula to say x equals, 6 plus or minus square root b squared minus 8 all over 2, right? AC, yep. So then, right, which is x equals 6 plus or minus square root 28 divided by 2. So again, I need to make a little bit more room here. It's just a lot of work, basically. Which can simplify to x equals, because root 28 can be written as 2 root 7, so then I can divide everything by 2 and have x equals 3 plus or minus root 7. Now, the thing is, I know that it has to be 3 plus root 7 because 3 minus root 7 is going to be less than 2. So then when I subtract the little 1 centimeter squares, I would end up with a negative length, which is not possible. So therefore, I know that x is 3 plus root 7. Now, remember, x and y have to add up to 6. That means y is 3 minus root 7, right? So, and remember, we want to know the size of the original index, which would be x plus 2 times y plus 2, right? Or xy plus 2 times x plus y plus 4, right? So that's what I need to evaluate. 3 plus root 7 times 3 minus root 7, that's going to give me 9 minus 7, or 2. So x plus y is 2. Remember, we found before that x plus y was 6, right? We found that before by looking at this, like if we solve this equation, we get x plus y is 6. So I can substitute here 6 plus 4. And if you add these together, you get 12 plus 6, which is 18. So the answer is E, 18. Okay, all right. And again, I think I remember doing this problem before, and I think I did it in a much simpler way, but for some reason I'm having trouble remembering how exactly I did it. I think there is a nicer way to do this problem than I'm doing it. I think I'm way overcomplicating it. So if you can think of a better way to do it, please let me know in the comments. I'm actually very interested to see that. So, all right, see you for number 11. Thank you.